So topic 5, which is related to chemical energetic. In this one, sulfur tetrafluoride is there. The reaction is exothermic. It is made by combining the gaseous sulfur with fluorine. The reaction is exothermic, and during a reaction, 780 joule. First, what we have to complete the energy diagram to indicate how the energy change. So this reaction is exothermic. So in exothermic reaction, reactant should have high energy and the product should have low energy. Then you will label from reactant till the start of a reaction. That is one more point which I want to mention. Like for example, if you draw for enthalpy change arrow, you draw a two direction arrow. That is not correct, because enthalpy change arrow is always from reactant to the product. So specifically you have to draw arrow which is starting from the reactant and ending at product. So only one direction arrow. If you draw two direction, you will lose the mark. Same way, when you show an activation energy, so if you draw activation energy by two direction arrow, that is also wrong. You have to show from a reactant till the start of reaction. So this will be activation energy, and this we will draw one direction arrow, and this will be the enthalpy change, delta H. So enthalpy change, arrow will point downward if it's an exothermic, arrow will point upward if it is endothermic, and activation is always pointing upward. But keep one thing in mind, that don't draw the two direction, like a single direction always from reactant to the product. During the reaction, the amount of energy given out is 780. We need the bond energy for fluorine and fluorine. So the idea is that the bond breaking energy minus the bond forming energy is equals to the enthalpy change, the energy change. Bond breaking energy is how much? Sulfur, there is no bond breaking energy because it's an atom. There's no bond. Fluorine and fluorine, bond energy 160. So this will be 160 multiplied by 2. That's a bond breaking. Minus, which is 320. Minus the bond forming energy. Sulfur can exist as an atom. Yes. Sulfur, carbon, silicon, they can exist as an atom. Sulfur exist, like sulfur 8 molecule is there, S8 molecule. So some elements can have a tendency to form a giant structure or giant molecular structure. So for those, we don't write them as a molecule. Like when we write carbon, we don't write C. It's like C60, C50, we just write C. Bond forming energy, which that is what we need, and how many bonds are formed? 1, 2, 3, 4. So each is unknown, so we can say 4x equals to enthalpy change. Because this reaction gives out energy, so even though it's written 780, but we'll write minus 780. So our equation will be 320 minus 4x is equals to minus 780. Now we simplify for x. So 320 is a positive, other side it will be negative. So minus 4x is equals to minus 780 minus 320. Because it was positive, other side negative. This will be minus 1100 is equals to minus 4x. So we need x. So it will be minus 1100 divided by minus 4. So when you simplify, it will give you 275 kilojoule per mole. Why I took a negative sign? Because in the question they mentioned during a reaction the energy is given out. So if energy is given out, the enthalpy change for experiments which energy is given out or released, it is always negative. So magnitude is 780, but the sign should be negative. So that's why you have to substitute negative sign. Is it clear? So 275 kilojoule per mole will be the enthalpy change. Any doubt in this?